Welcome back. In this lecture, we are going to understand about AWS EKS Storage. So in EKS Storage, we have different type of drivers and then provisioners. So if you see here, we have Install EBS Provisioner, EBS CSI Driver, EFS CSI Driver, and then FSX for Cluster CSI. So Install EBS Provisioner is a legacy one and will be soon deprecated. So we are not going to look into that. And future it is going to be with the CSI drivers only. So what does that CSI mean is like container storage interface. So with EBS, which is nothing but elastic block storage, which is for persistent volumes, so we can use EBS CSI driver. And we also have elastic file system, which is a fully managed file system by AWS. So if we want to use it, we can use EFS CSI driver. In addition to that, regular FSX for Cluster CSI will be available for Windows file systems and other stuff. But the core thing here is we are going to primarily discuss on EBS CSI driver in our upcoming continuous lectures, and then we are going to use this EBS CSI driver, leverage this driver, and then use the EBS service in AWS to have the persistent volume mounts for our MySQL database. But let's see this a little bit about these drivers. So these are the latest and greatest available today, and they are in beta releases, but they are also ready for production use. And as on today, so these drivers are not supported on AWS EKS Fargate, which is nothing but serverless infrastructure. And it allows EKS clusters to manage lifecycle of EBS volumes for persistent storage, or EFS file systems, and FSX for Cluster file systems. So entire life cycle of these respective services, which is EBS or EFS or FSX, can also be managed using these drivers from EKS. So now EBS and then EFS are supported for Kubernetes 1.14 and then later versions, and FSX for Cluster CSI is supported from 1.16 and then latest versions. So now moving on, so let's see little bit more about the EBS CSI driver, right? So before going in, so let's understand what is this elastic block store before moving on. Okay, so EBS provides block level storage volumes for use with EC2 and then container instances. So we can mount these volumes as devices on our EC2 or container instances. So EBS volumes that are attached to an instance are exposed as a storage volumes that persist independently from the life of the EC2 or container instance. In simple terms, even if we terminate our EC2 instance, or even if we terminate, or if our container instance got terminated, or our respective Kubernetes pod got terminated, still volume is persisted independently. So we really don't need to worry about the data stored in those volumes, right? So we can dynamically change the configuration of a volume attached to an instance. We can increase the size of the instance, means like we can increase the size of the volume or decrease the size of the volume. We can do all those things. Okay, so AWS recommends EBS for data that must be quickly accessible and requires long-term persistence. So EBS is well suited for both database style applications that rely on random reads and writes, and to throughput intensive applications that perform long continuous reads and then writes. So for in both ways it is useful. So now let's see what we are going to build on a high level. So in a EKS cluster, so we are going to create a deployment which is nothing but the MySQL deployment. So for this respective MySQL deployment, we are going to leverage the elastic block store as the volume mounts inside this deployment, which means for this MySQL database, we are going to use data volume mounts as from elastic block store. So in addition to that, as part of this deployment, whenever we are creating, right, so we need to learn few other Kubernetes concepts here. One is storage classes, persistent volume claims, config maps, environmental variables, volumes, and then volume mounts. So all these things we are going to learn as part of this entire use case. In addition to that, so unlike earlier, which means like earlier we used to use a persistent volumes first, means like as a Kubernetes administrator, I used to create a storage class and a persistent volume, and then I need to go and then claim that volume using persistent volume claiming. So, but now we are going to use the another latest feature, dynamic volume provisioning here. Okay, so that is going to come in, and then we'll discuss whenever it comes, we'll discuss in detail about that. But for now, let's move on with what we have. As part of that, as usual, again we are going to understand about node port service and then deployment of MySQL. So I also changed this to ClusterIP service because this deployment is going to use MySQL deployment is going to use the ClusterIP service. So moving on, so once we complete this, means like creating the storage class related Kubernetes manifest, persistent volume related manifest, and then ConfigMap related manifest, and deployment with environmental variables, volumes, and then volume mounts, and then ClusterIP manifest. So once we complete 1, 2, 3, 4, 5 manifests, then we'll move on to the next thing, which is nothing but our user management service. So we have created a persistent database, but how we are going to know that? By integrating it with an application, we will know better, right? So that's the reason I have created a simple Spring Boot user management microservice. So wherein you will be able to create the users. Whenever a user is created, it will come and then store it in the MySQL database. And whenever you delete the user, it will be deleted from the MySQL database. Whenever you list the users, it will fetch the users from the MySQL database and then show it to you from your Postman client or from browser or whatever, right? So whatever the client we are using. So all those things we can do. So that type of application we are going to deploy here and then create a deployment for that. So which means we'll create a deployment with the respective environmental variables here, which is nothing but why do we need to have environmental variables in this deployment is nothing but these environmental variables will have the database information to connect to this respective database. So what is the DB host, and then what is the DB username, DB password, and what is the schema we are going to use. So all those things. So the schema, whatever we are going to create inside this MySQL database is user management schema, which we will define in this ConfigMap, and then that will get created. So we'll create a deployment with environmental variables to connect to this respective MySQL here. And in addition to that, we are also going to create a node port service to access the users. Means like for access to users, we are going to create a node port service so we can access it via internet. So all these things we are going to do. So let's go back one more time to our GitHub repo and go to our EKS storage with EBS Elastic Block Store. Okay, so if you see here, we are going to use EBS CSI Driver and use EBS volumes for persistent storage to MySQL database. So the core topics involved here are first installing the EBS CSI Driver on our Kubernetes cluster, and then create the MySQL database deployment and then ClusterIP service, and finally create the user management microservice deployment and then node port service. So as part of that, the following Kubernetes concepts are covered: storage classes, persistent volumes, config maps, environmental variables, and then node port services, environment variables, all these things. And in addition to that, after this entire section is completed, the entire EBS section is completed, all these things, and then if you still have doubts or if you want to implement few things, whatever is not referred in this section, again you can definitely go to these references and then look into. So why? Because we are using here only the dynamic volume provisioning here, but you can even do the static provisioning or even resize your disks, or there will be different options available here, and then you can use these reference links to understand better and then change whatever you want, or in your real world environments based on your requirements, whatever you want to do, you can use these things. Okay, so I'll see you in the next lecture by moving on with installing EBS CSI Driver. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to install the EBS CSI Driver on our Kubernetes cluster. So we are going to create an IAM policy for EBS and associate that IAM policy to our worker node IAM role. So and then install the EBS CSI Driver. So once we create this role and then associate it to our EBS EC2 instances, means like EKS EC2 instances worker node IAM role. So which means like the pods inside the Kubernetes will be able to access that respective EBS services from the Kubernetes cluster. So let's go ahead and then do that now. So go to services IAM and then create a policy with following details. So let's copy this and then go to IAM service, right, and then go to policies and then create a policy, right, and go to JSON and remove existing and then add this and go to visual editor, and it will validate the entire policy here, and the following EC2 actions it is going to pick as part of this. Whatever the JSON we have copied, it has picked close to 12 actions from EC2 and review policy and provide the name of the policy, right? So the name of the policy we are going to say is Amazon EBS CSI Driver, right? And even we can say that for EKS so that it looks good if you want. Okay, so EC2 instance is access for EKS. Okay, so and then create a policy, right? So once the policy got created, get the IAM role worker nodes using and associate this policy to that role. So you can get your IAM roles on our EKS cluster using this command eksctl in the kube system namespace describe ConfigMap AWS auth. So we can get this way. The one way of getting it is this way. So let me go to terminals. So I didn't have my terminal open. So let's go here and open the terminal, right? Make it bigger. Okay, so and then let's paste this kubectl -n kube system, which is in kube system namespace describe the config map AWS auth, and it should provide the role ARN. So this is the role ARN, so which means like we need to search for this in the IAM, and then under this we need to associate the policy whatever we have created, right? So we are here now and we can go to roles and then search for that policy. Okay, so I have copied this and I have copied from eksctl here. Okay, so from here I have copied this and then searching here and then I got the policy role here. Okay, so inside this role we can attach the policy, right? Attach, and I can say Amazon EBS CSI Driver. So this one we are going to attach to our worker node IAM role. So the other way of finding the role is, so we can go to EC2, right? And in EC2, if you see here, we'll have the running instances, and in that we'll have our T3 medium related EKS cluster related instances. If you see, these are related to EKS demo cluster, right? So now I can go here and then I'll find the IAM role here. Okay, so you can see, right, IAM role. So I can click on this directly and then associate if I want to, right? So if you see, already it is associated. Just now we have associated. So this value and this value should be absolutely same, right? So 1K8 and 1K8. Okay, so in both ways we can go ahead and then identify our IAM role, right? So now we have provided the equivalent permissions for our EC2 instances present in the EKS cluster. Now we can go ahead and then deploy the EBS CSI driver. So we should be 1.14 or later. So let's verify our version. So we are at 1.16.6 beta. So good. Okay, so now we are going to deploy the Amazon EBS CSI driver, right? So I'll copy this entire thing and then paste it. So it will reference to the Kubernetes special interest groups AWS EBS CSI driver GitHub repo. Okay, so I am deploying it. Okay, so whatever is the latest as on today, it is going to deploy that version. So it will take a while. So it is creating the cluster roles, daemon sets, all whatever is required, it has created. So what we can do is, so I can say get pods -n kube system. Okay, so this should be created in kube system. So let's cross check. Okay, so you can see it has created the EBS CSI controller and then EBS CSI nodes here. Okay, so I'll also add this there. Okay, so in our document. Okay, so it has created and then it is up and running. So in our next lecture we'll focus on the next concept. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create the MySQL related Kubernetes manifests which are required for us, and then we are going to build them using live template writing, and then we are going to deploy and then see that how the MySQL is going to come up with the persistent storage using Elastic Block Store, which is EBS service in AWS. So let's go to 0402 SCPVC, which is nothing but storage class, persistent volume claim, config maps, and then MySQL deployment and then service. So we are going to create 5 manifests here. So we'll start with our step 1. So if you see here, we are going to create the storage class manifest, persistent volume claim, user management config map, MySQL deployment, and then MySQL ClusterIP service. So let's start with the first one, which is our create storage class manifest. Okay, so let's go back to our Visual Studio Code here, and I have created the empty files here and then put them ready for our development of live template writing. Okay, so we are in the 01 storage class. So as usual, we are going to create our basic template first, which is nothing but API version, kind, metadata, and next is spec, right? So now let's start with the API kind. Kind is nothing but we are going to create a storage class. Okay, and next is API version. So for storage class, the API version is going to look like this. Okay, storage.k8s.io/v1. So let's see in our API specification document too. So we can see it here now, storage.k8s.io/v1. So that's what we have implemented it for our storage class. And now the metadata we are going to give as tab and then name, and then I'm going to say EBS storage class. Okay, and now when coming to the storage class, it is not going to be spec here. So it is going to be the provisioner. Okay, so who is going to be the provisioner? My provisioner is going to be, if it is Azure disk or if it is GCE persistent disk, then the provisioner is going to differ. And now we are going to use it in AWS. So it is going to be ebs.csi.aws.com, right? So, and now one more important thing here we need to work on is volume binding mode. So this can be immediate or wait for first consumer, right? So let me save this and then see what is this wait for first consumer. So let's come back here, and if you see here, this wait for first consumer mode will delay the volume binding and provisioning of the persistent volume until a pod using the persistent volume claim is created. So what happens is, like, whenever the storage class you created, and then whenever you create your persistent volume claim, so if you don't add this volume binding mode to wait for first customer, then it is going to immediately dynamically provision and then mount your volume. So means like it is going to provision your volume there. So in which availability zone we really don't know. It is dynamic, right? So it can be in availability zone 1 or means like US East 1A or US East 1B, we really don't know. And whenever you go ahead and then later you go and then create the pod, what happens is, like, if your volume is mounted in US East 1A and your pod got scheduled or created in US East 1B, then you have the issue, right? So considering all those things, there is a new option provided here, wait for first consumer. So what happens in this case is, like, whenever you create the pod, at that time only it will provision the equivalent volume for you. So what happens at that time is both will get created in the same topology, which is nothing but in the same availability zone. So that is one key important thing. So that's the reason whenever we are using in our AWS here, we can use wait for first consumer. Anyway, even though using EBS with MySQL databases here on Kubernetes, it will have equivalent setbacks and then drawbacks. We'll see in our later lectures those things, and then already a next lecture is planned in detail for this, like to avoid these EBS related issues. So then how we are going to use the RDS database in Kubernetes cluster, all those things already planned. But for now, let's go ahead and then start writing our template related to config map and then persistent volume claims. So we just now completed the storage class related manifest. Okay, so in our next step, we are going to create the persistent volume claim related manifest. So I am not going to go for everything to API version. We are not going to go to refer the API reference doc every time. So you can refer whenever you have time there. But for now, we'll go with the standard stuff here. Okay. So this is the standard API version, kind, and then metadata, and then spec. And now what we are creating is persistent volume claim, right? And its version is going to be v1. And in metadata, our standard thing is to create a name, right? So I'm going to say EBS MySQL PV claim, right? And in spec, we'll have three things on a very high level. That is access modes, and next is storage class name. This respective persistent volume claim need to refer, right? And next is resources. How much you want to reserve the space, means like how much you want to take the space for your respective mount point of your MySQL database example, right? So your volume mount, how much you want to take. So let's start with access modes. So we want read, write once, okay? And the storage class name, whatever we created here, is EBS SC, right? EBS storage class. So I'm going to give that. And resources, in that we are going to request how much, okay? So we are going to request the storage, and the storage is going to be 4 gigabytes, okay? 4 GI, okay? So that's all. Now we have completed the persistent volume claim related Kubernetes manifest, okay? So we'll also complete user management ConfigMap manifest, and then we'll go to the next one, okay? So we are going to create a ConfigMap manifest which will be mounted in our MySQL deployment, so that whenever the MySQL pod is got created, automatically it also need to create one small schema named user mgmt schema. So that we will use for our user management microservice deployment. So whenever the user management microservice is deployed, it expects that there is a user mgmt schema present in your respective database. So for that purpose, we introduced the ConfigMap concept here. Means like, why ConfigMap is like whatever you want to do, whatever the configuration you want to send to your pods, right? In whatever the way, you can define it as a config map and then mount it in your container. So we are going to container definition, which is nothing but our deployment. So we are going to do that so that we'll know the use of config map, how we are going to use it. So standard API version, kind, metadata, and here it is not spec, it is going to be data, okay? So and what we are going to create, config map, and the version is going to be v1, and the metadata, and here I'm going to write the name. It is going to be user management -db creation script, okay? So in data, I'm going to create a MySQL _ user mgmt.sql script, okay? So, and I'm going to write the content of my SQL script, okay? So I'm going to say drop database if exists, okay? And database name is user mgmt, okay? And then create database user mgmt. So we can give small or big, whatever it is, okay? So create database user mgmt. So this is about creation of our config map. How we are going to mount it in our MySQL deployment file, we are going to see in our next steps, okay? But for now, one thing we need to understand here is, let's save it and go back here. So these are few steps to execute here in persistent volume claims manifest. That is nothing but let's create storage class and PVC and then list them and then see how it is going to look like. We discussed about wait for first consumer, right? So what happens, we are going to see here now. So let's go here and go to, what is this section? Section is 04, right? So let's go to 04, and in 04 we'll have something called kube manifest. We need to go to 0402, right? Inside that you will find kube manifest, right? Right, we have that, okay? So I'm going to say kubectl apply -f kube manifest. So it need to create three things for us, okay? So storage class, persistent volume claim and its equivalent DB creation script related config map. So I'll say kubectl get sc, which is nothing but the storage class. Okay, and I have got my EBS CSI AWS.com, which is the EBS SC got created. So now I'll say get PVC, which is nothing but persistent volume claim. Now you can see, right, it is waiting for the first consumer. You can see the status is waiting, so it is not already allocated or volume already binded. Okay, so if you want get PV, nothing. So persistent volume still not yet created. Volume claim is waiting to create the volume until and unless the pod got created. It is not going to create it. Okay, it is not going to bind the volume and then create the persistent volume. So let's wait for it. Okay, so now we have completed these things. So let's, if we want, we can even delete it or we can leave it as is. Okay, that's not a big deal. Okay, so in our next lecture we are going to focus on creating the MySQL deployment and then MySQL ClusterIP service, and then we'll move on with creating those deployment service, all these manifests, and then testing it. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Back. In this lecture, we are going to create the MySQL deployment manifest. As part of that, we are going to create environmental variables related to or MySQL deployment related to root, password, and all those stuff. And we are going to create the volume mounts and then also create the volumes for our container, right? In addition to that, we are also going to create MySQL ClusterIP service manifest. So let's go ahead and then do that now. So let's go to our Visual Studio Code and we will start with our MySQL deployment. So as usual, we'll start with API version and then kind, metadata, and spec, right? And now our kind is nothing but we are going to use deployment, and its version is apps/v1, and we are going to say metadata, we are going to say the name as we are going to create a MySQL deployment. So I'll just say MySQL, and under spec we'll have 3 top level objects. Okay, so ideally we'll have something called replicas, and we'll have selector in general, and then template, which is nothing but our pod template, whatever we are going to write. But here we are also going to have one more extra, which is nothing but, if we want, we can define usually strategy. Okay, so our strategy type is going to be rolling update or recreate. Okay, so we are going to say recreate. It's a database, right? So whenever this pod terminates, again recreate that pod. Okay, so that's what we are saying. It will always be only one replica, this database, and we really don't need to have any rolling updates or those stuff. Okay, and the selector, we know that we'll have something called match labels under that. So let's define our match label is app is equal to MySQL. Okay, so the same thing we need to define for our container related template metadata labels also. Okay, so now under template, again we are going to have 2 things, right? So one is metadata of your pod, and second is spec. Okay, so now under metadata you are going to define, if ideally we really don't need to define the name of our pod here because it is part of the deployment, right? So if we define labels, that will be sufficient. Okay, and it should be same as our respective match labels, whatever we defined here, app is equal to MySQL. So now under the spec we'll have the child elements. One is containers and the other is volumes. Okay, so 2 things. Earlier we used to have only containers in our previous whatever in our Kubernetes fundamentals are everywhere. So now we are introducing the concept of volumes. So we are going to also add volumes here. Okay, so now in the pod template spec we have created, we are going to add containers and then volumes. So let's start with the containers now. So under containers we are going to have a name of my container, okay, and the image name, right? And so name of my container is MySQL, and I'm going to use the MySQL 5.6 container image. Okay, and now container is done. So something I need to provide for MySQL container is environmental variables. Okay, So I'm going to define those things. Okay, so that is going to be, what are those things? Okay, MySQL underscore root underscore password, and its value is going to be db password 11. So we are going to use db password 11, right? So for the container, one more thing important is, right, ports. So let's define the ports, right? So I'll say container port is equal to 3306, and name of this port I can say MySQL port, right? So that's the thing. So for now we'll leave it here, and then we'll, under containers, for this container we have the environmental variable and all those stuff defined. So now if you see here, you can find a little bit of mistake here. You can see, right? So under containers you have a container name MySQL and the image. So this env and then ports also part of this container, right? Name MySQL. So we need to do this way. So now if you see, name, image, env, ports all are under single line now. You can see that, right? So that's good. So now the next thing is volumes. Okay, so these are again one more top level, right? Under spec, one is containers, another is volumes. So we are going to define two volumes here. Okay, so now let's start with the first volume. Okay, so and the name of the volume is MySQL persistent storage, and here we are going to mount persistent volume claim, and claim name I am going to provide is EBS MySQL PV claim. So whatever we have created here, right? EBS MySQL PV claim, the same thing it should be here. Okay, so now what happened is we have mounted for our respective container one volume which is MySQL persistent storage with name, and we are mounting the persistent volume claim named EBS MySQL PV claim. So one more we need to map, which is nothing but our ConfigMap user management DB creation script. We are going to map it. Okay, so user, so we can go here and then get that name. So it's a big name, so let's copy it here and then come back. Where is this? Here, right? And paste the name here. Okay, and now we are going to have something called, it is of type ConfigMap, right? And what is the name of the ConfigMap? It is going to be the same thing whatever we have copied just now. Okay, and I'll say script. Good. So now we have mounted the volumes also. So now these volumes we are going to use as volume mounts inside our container, right? So these are the volumes available for us which we need to mount in our respective container named MySQL. Okay, so let's go ahead and then mount those volumes in our container. So for that purpose, equivalent, like how name, image, env, ports, at the same level you need to write something called volume mounts. Okay, so now you can define here name of the mount and the mount path. Okay, so now name of the mount is MySQL persistent storage. So I can give the same name here, right? And mount path I am going to use is var lib MySQL. Okay, so which is nothing but the storage of MySQL will be present in var lib MySQL. So we are mounting that folder to our container, MySQL container. So one more we will have. So again name and then mount path. Okay, and we are going to mount the user management DB creation script. Okay, and when you want to mount it, during the docker entry point initiation db.d. Okay, so we'll see what it is shortly. Okay, so docker entry point init db.d. So let's come back. What does Docker entry point initdb do? So when a container is started for the first time, a new database with the specified name will be created and initialized with the provided configuration variables. So we are going to create user mgmt database there and using the .sql MySQL DB script .sql. Okay. So whenever the container starts for the first time, so it is going to create that. So that's what we have created it in our ConfigMap. The drop if any database exists and then create the database user mgmt and then mount it. Okay, so mount it here so that, and then use the docker entry point initdb here. Whenever you mount, then the mount path you are going to use docker entry point initdb, so that it is going to run this script whenever the first time the container is going to start. So it will run this MySQL user management.sql script. So that's about it. So now we are going to go ahead and then create our ClusterIP service now. So we have completed the deployment part, which is nothing but the MySQL deployment we have completed. If you want, we can see one more time. So we have created the base template here, and then after that we, under the spec, we have something called replicas, selector, strategy, and then template. So template is pod template. Strategy is as it is database, it need to recreate. There is no rolling or another strategies applied. Standard recreate type we are going to apply. And selector is going to be under match labels app MySQL, and replica always it is going to be one pod. So it is one. And now under the pod template, as usual, metadata and spec will be available. And metadata, we have defined our pod label as app is equal to MySQL. And under spec, we'll have two things here, containers and then volumes. So we have created two volumes. One is for the persistent storage, mapping it with our EBS MySQL PV claim, whatever we have created. And the second is user management DB creation script, that is nothing but the ConfigMap. We have mapped those two volumes, and then these two volumes will be mapped to our respective pod, and from pod we are going to mount it to our container, which is nothing but our volume mounts here. And in the volume mount, we are going to create a mount for MySQL persistent storage under the mount point, where live MySQL, which is nothing but the core MySQL database storage data files path. And the another is user management DB creation script under the mount path, docker entry point initdb, which is nothing but whenever our container is going to start for the first time, so whatever is present in the config map, it is going to run. So that's about the MySQL deployment. In our next step, we are going to create the ClusterIP service. So let's go ahead and then create the first time, which is nothing but v1, and kind is equal to service, and I'm going to say metadata, and I'm going to say name, which is going to be MySQL. Okay, so and next is going to be spec, and it is a service. So and it is a ClusterIP service, whatever we are going to create. So we are going to have selector and then ports usually. Okay, so and I'm going to give the port as 3306. Okay, and the selector is going to be app is equal to MySQL, which means whatever the traffic comes to this service, it need to route to the pod whose selector, whose label matches with app is equal to MySQL. Now another thing important here is, we already know that MySQL deployment is going to be always only one pod. So which is nothing but this is the only one pod. So we are not going to scale it, or we are not going to have multiple replicas. If we know that is going to happen, so we can do one more setting in our service, which is nothing but cluster IP is equal to none. What does this mean? This means, okay, so we are going to use pod IP directly. Okay, so we really don't need to allocate a separate IP address in our network for this respective cluster IP service MySQL. We can leverage directly using the pod IP whenever you say cluster IP is none. So that's about the entire spec creation, whatever we have created for MySQL deployment and then MySQL service. So this completes the step 2, which is nothing but creating of our entire manifest. Okay, storage class, persistent volume claim, user management config map, MySQL deployment, and then MySQL cluster IP service. Okay, so in our next lecture, we are going to create these things and then test these things, connect to that MySQL database, and then test it end to end. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. in this step, we are going to create MySQL database with all above manifest whatever we have created, right? So we are going to create it and then verify the storage class PVC, PV pods, and then also list the pods and then connect to our respective MySQL database and then see the schemas. Okay, so let's go ahead and then do that now. So we are in our respective folder, which is nothing but 0402 SC PVC ConfigMap MySQL. Okay, so kubectl apply -f cube manifest. So whatever the manifest under that, it is going to create it. If any issues, it is going to throw the error and then we are going to know about it. So we know that under the ClusterIP service, we have a validation error. I didn't provide cluster means CLUSTR. I didn't provide the T here. Okay, so let's go there and then fix that. Okay, so ClusterIP, right? So that's good. So now let's try one more time. So it should get created and the service also got created. So now if you see the get PVC persistent volume claim, so now it is bound, you can see, right? So earlier it is in pending state whenever we have directly created them and then no MySQL pod got created. So now we'll see PV, which is nothing but persistent volume, got created and then it's in use. Okay, it's bound. Okay, so this is the persistent volume, it got created. So now let's go back and then see the pods, right? So our MySQL pod is running. Okay, so that's about it. So if you want to find it with the respective label, means like app is equal to MySQL, so you can do like this. Okay, -l app is equal to MySQL. Even you can list using MySQL pods. That's all. Okay, so how to use labels? This is a just simple command. So now we'll move on to connect to this MySQL and then see what happens. Okay, so let's use the command kubectl run and then use the interactive terminal IT and then delete this pod whenever it has been exited, and then we are going to use image, right? MySQL 5.6 for our client also, restart never, and then MySQL client, and then MySQL -host is MySQL only. Why? Because whatever is running is a MySQL service only, right? And the password is db password 11 for our root password. Okay, so let's run this and then see what happens. Okay, so right, so we should get the MySQL terminal ideally. So let's see. It is taking little bit of time. If you don't, yeah, we got it. Okay, so now if I say show schemas, so I should have, in addition to default schemas, user mgmt schema. So it got created. So whatever we have defined in our config map under data, the MySQL underscore user mgmt.sql got executed, and it also created the user mgmt schema. So with this, we have completed the creation of our entire section, which is creating a storage class, creating a persistent volume claim, and then using the dynamic provisioning, and we have created the config map, and then we have also created the deployment for MySQL and also the ClusterIP service for MySQL. Okay, so if you want to see, we can even see. So I can exit from this. So I'll say quit, and my container, my pod got terminated. Okay, MySQL client pod got terminated. So good. So if I say kubectl get pods, and I should have only one pod now. Yeah, and then I should see SVC, which is our ClusterIP service. So that's good. Okay, so now this is about the entire stuff. In our next lecture, we'll discuss little bit about the references section, and then we'll close this entire 0402 section, and then we'll move on to user management service. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture, we are going to discuss about the references section exclusively, mainly related to EBS CSI Driver. So I have provided all the links for you for your additional understanding, and then more about the features available there and all those things. So this is the core link about our EBS CSI Driver. So we can go in there, and this is the dynamic provisioning, whatever we have implemented, and more examples are provided here for additional stuff here. So let's go here. Okay, so this is the EBS CSI Driver, and if you see the current version it is running is v050. And whenever you are testing, it might be even 1.0 or whatever, right? But whatever it may be the case, so the core thing here we need to understand is here. Okay, so whatever the features it provides: static provisioning, dynamic provisioning, mount option, NVMe, block volume, volume snapshot, and then volume resizing. And important things when we are seeing the features is alpha state. Okay, so volume resizing and volume snapshot are in alpha state, and they are sometimes working, sometimes not working. They are unstable as on today. So that's the reason I didn't include these things. Okay, so block volume is in beta stage, and this dynamic provisioning, these are also in beta stage, but the thing is they are ready for production. That's what AWS says, so we can use these things happily. But the core thing is, whatever you see alpha stages, you cross check before you are using for your things. Means like when you want to use resizing, you need to say allow expansion true in your storage class. Okay, I didn't define that here. Allow expansion true, you need to define an additional tag here. Okay, so but as it is in alpha state, it is not good to add that and then demonstrate it. Okay, so it might change the why, because once it comes to beta, the changes will be minimal, but if it is in alpha, the tag might change or whatever it is. Okay, so that's about it. Don't worry about installation steps, whatever here provided. So you need to follow the steps whatever I have provided here, which is straight and then easy. And now next thing here is one more thing is this is the one examples for EBS CSI driver. So we have implemented dynamic provisioning with our MySQL, and we have for block volume and then for resizing. So if you see the resizing, allow, I told you, right, allow volume expansion true. So like this you can provide all these things, but whatever you want to provide, and then based on your requirement what you want to use, accordingly you can refer these examples. Means like you can go inside these examples and then go inside this spec and then find the example.yaml or whatever, and then find the options related to your storage class and then persistent volume accordingly, and then leverage and then use it whenever you are doing in your real-time environments based on the requirement whatever you have. Okay, so that's about the references section here. Okay, so dynamic provision, direct link I have provided, and resizing, snapshots, everything you can see here, all the examples here. Okay, so in our next lecture we'll focus on creating the user management microservice, which is connecting to the MySQL database we have created. We'll create some users and then reference them in the database and list those users and everything, and then again we'll clean up everything. So that's about it. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture we are going to create the deployment for our user management microservice, and also we are going to create the user management node port service related Kubernetes manifest, and then also provide the environmental variables required for this application to connect to the MySQL deployment whatever we have created earlier, right? So let's go ahead and then do that now. So let's go to our GitHub repo and we'll go to 0403 user management microservice with MySQL DB. So we are going to create two YAML file manifests, so microservice deployment and then also node port service. So as part of that, we are supposed to provide the following environmental variables to our respective container, which is nothing but the user management service container. So let's go ahead and then do that now. So now if you see here 0403 user management microservice, and inside that kube manifest, so whatever I have created, the 5 things, whatever as part of 0402 storage class and then persistent volume, claim, ConfigMap, and then MySQL deployment. So all those 5 I have copied back here, whatever we have created in our previous lectures. Okay, so now we need to create 06 and then 07 microservice deployment and then microservice node port service. So if you see the base template related to our Kubernetes, which is API version, kind, metadata, and then spec also, I have put it here. So what we need to do? So now we are creating the user management microservice deployment. So the kind is going to be deployment, and for deployments the API version is going to be app/v1, and for metadata we can say it is going to be name, right? So user mgmt microservice, and we can also give labels if you want to, and I'm going to give the label as app:/user mgmt REST app, or even microservice, whatever you want to give. So now we are in the spec part, and under spec we'll have 3 core child elements for a deployment. So one is replicas, and second is selector, and third is going to be pod template. So now replicas, we can start with one replica, so that's not an issue. And selector means in deployment we'll have something called match labels. Okay, so and whatever we are going to give here is app and then user mgmt rest app. As usual, whatever is present in match labels, pod template labels also we need to have the same value. Okay, so under template means like this is nothing but this is the pod template, and under pod template we are going to have two core things. Okay, so child elements, okay, metadata, and one more is going to be spec, which is nothing but pod specification. Okay, so and under metadata we are going to have labels only. Name, ideally we are a part of deployment, we really don't need to give pod name here. Okay, and the label we are going to give the same thing whatever is present here. Okay, so good. So still here we are good. Under template we have two child objects, metadata completed. Now we are writing the spec. So under spec we'll have something called containers, and then if we have any volumes to be mounted to this pod, then we can have volume, but currently we don't have anything, so we have only containers, right? So containers is a list, and then you can have one container under this, which is name and then user mgmt rest app, and it's image, right? Container image you are going to provide, right? So we'll provide that shortly. And next is going to be container ports, right? So let's define the ports here, and I'll say container port 8095 is my application port for user management microservice. So means like which is my container port, whatever I have defined in my application whenever I built the container, it is 8095, so I am providing it. So if you want to give the name of the port also, you can give with the tag name if you want to. Okay, so I am leaving it. Okay, so all those are minor things, so I am leaving it. So we have completed name, image, and then ports. So the next thing is going to be the env, right? So let's complete the environmental variables. So under environmental variables we provide it as key value pairs, right? So and environmental variables are also a list. Okay, so we can have name and then value like this. Okay, so we are going to provide db hostname, db port, db name, db username, and then db password. So 5 things. Okay, so we need to have 5 things like this. Okay, so let me copy paste, and 2 3 4 5. Okay, so now let's start with the db underscore hostname. Okay, my db underscore hostname is going to be MySQL. Okay, so that is what is my thing, whatever we are defined here, right? So and the next is db underscore port, right? And the value of db underscore port is going to be 3306. Put these in double quotes and ensure that we have the db name, so which is nothing but our application, means like user management application, to which schema in our database, MySQL database, it is going to connect to. So we have created a schema named user mgmt schema, so we can use that. And the next is db underscore user name, right? So we have going to use root user, and root user password also with MySQL underscore root underscore password we have defined it as db password 11. So let's define the variable db password, and I'm going to provide it as, so let's also provide the db password. So whatever we have given in our MySQL deployment here, which is nothing but MySQL underscore root underscore password, the same thing let's provide it here, right? So which is nothing but db password 11. Okay, now let's also update the image name here. So let's go to our Docker Hub, and if you see in the repositories, you will find something called Kube User Management Microservice. Okay, so inside that you will have 3 tags. One is 1.0.0, 2.0.0 h2db, and then 3.0.0 x-ray. So whatever you find 1.0.0 is going to be the user management microservice connecting to the MySQL DB. So you can take this tag completely, user cube user stack simplify cube user management microservice : 1.0.0, which is nothing but this one. So usually I have also in the readme updated that this needs the following environmental variables passed to our respective container, right? So now let me copy this and come back and then add it here. Okay, so now this completes our microservice deployment creation. We'll move on to our user management node port service, whatever we want to create. So let's start with the kind is service and the API version is v1, and the name of means like under metadata will have usually 2 child items, name and then labels primarily, and in future if you want to use namespaces you will have the namespace item, but we are not using anything like that for now. We are going to go to the default namespace, so we leave it like this. Okay, and user mgmt hyphen rest app hyphen service will be my service name, and under labels I'm going to give it as user mgmt app rest app. Okay, so now the next thing is under spec. So we'll have 3 things usually under a service, which is under spec child elements, primarily important ones. So selector and ports. Okay, so type, selector and ports. So as we are going to create a node port service to access this user management application via internet, so we are going to create it as node port. And next is selector. So selector is nothing but whatever is present in the pod template label, which is nothing but, so in the pod template label, whatever is the label, so we need to provide the same thing here, so that what happens is whatever the traffic comes to this service, it will be able to send to that pod based on this label. Means like it can select that pod based on this label whatever we provided. And we'll have 3 types of ports. So one is we have provided the ports, and under that one port will be our service port. Port is nothing but service port, and our container port, so we can give it as 8095, same thing, and we can even define our node port whatever we want. So now again we can say it as 31231. Okay, so this completes the creation of user management node port service also. So we have created deployment and then service. So in our next lecture we are going to test these things and then understand how it is going to behave. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to create the user management service deployment and then node port service. So as part of that, we are going to create all the things one more time. If you see here, so whatever we have created earlier, which is nothing but kubectl get all, so the storage class and then persistent volume claim and already deployment of MySQL and then MySQL ClusterIP service, everything I have deleted. So there is a reason for it. So let's go ahead and then observe why we have deleted. So whenever you are executing this kubectl command, so which is apply -kube manifest, you should be in those respective folder for that section. So we are in 0403 user management microservices with MySQL DB, right? So inside kube manifest, you will have all the 5 things now. Okay, so 01, 02, 03, 04, 05, 06 and then 07. All these 7 things, templates, whatever is there, all are available. So let's come out of kube manifest and then say kubectl apply -f kube manifest. Okay, so it is going to create all this stuff now for us. Okay, which is nothing but storage class, persistent volume claim, ConfigMap, deployment service for MySQL and deployment service for our user management service. So let's see the pods now. Okay, so now container is creating, but already user management microservice container already got created. So if you see logs -f, so what happens is before MySQL got created, user management microservice got created. So but it will fail because MySQL is not ready. It will restart the pod. So you can see it now here. Okay, because it's MySQL is not available, it will restart once, and after that again in the next restart, if it finds the pod, then it is going to MySQL pod, then it is going to connect to that MySQL. Okay, so now let's see what happens. Okay, see now it is user management microservices up and running. So it has restarted the container for the fact that for the first time MySQL is not ready. So to identify this type of issues, I have deleted everything and then whatever we have done during the MySQL section and then recreated now. So how to solve this? Okay, so which means our application container should not start before the MySQL container starts. So how to do this in our next section we are going to look into. But for now, our application is up and running, which is user management, and also our MySQL pod is up and running, right? So if these two are up and running, what is our current job is to get the node port and the node IP address, right? So 31231, whatever we have given directly in our service, so we'll get that, and we'll also get the node public IP address and take that and then access it and then test it on the browser. So this is the external IP. So we will use this IP, any one of the IP we can use it. So let's go here, right? So http://IP:, and then 31231 is our node port, and the context should be user mgmt/health status page for our microservice application. The same thing will be present for you in our documentation also here. So if you see here, this is the one, EKS worker node public IP, 31231 is the port, and user mgmt/health status. Okay, so this tells that our microservice application is just up and running. So let's access this and then see what happens. Okay, so if I make it bigger, user management service is up and running and the version is v1. So you can very clearly see that our REST application is up and running, or our microservice application is up and running. So in addition to that, if you want to see kubectl get storage class, persistent volume claim, and also persistent volume, you can even see those things now. So storage class EBS CSI AWS is provisioned, and its a volume claim also bounded to the volume, and this is the volume with 4 GB capacity. Okay, so which is here, right? Default EBS MySQL PV claim. So that's about it. So now in our next lecture, we are going to focus on test the REST services present in this user management application using Postman. Okay, so I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to test our user management microservice using the Postman. So we are going to download the Postman client and then install it using this link, and then import the Postman project AWS EKS master class microservices _postman collection.json present here. So which is nothing but this one, and then just import that to our Postman client and then create the environment required for that, which is nothing but with our respective public IP and then port, node port, whatever is there, create the environment so that the URLs present inside that are going to get replaced, and then test all the services like create user, list user, update user, delete user services. Okay, so let's go back to our Postman client. So if you see here in the import, right, so once you download and install your Postman client using the import, so you can copy that respective file, whatever you have, which is present here, whatever I have shown you, right? So this one, you can, this JSON file you can import. So once imported, it creates like this, which is nothing but, so this is the collection name and this is the user management microservice. Okay, so inside this, the first thing is user management health status, right? So before doing that, what we said is we are going to create the environment for that, which is nothing but using our worker node public IP and then port. So we need to go to settings here in the right corner, click on that, so that we'll be able to create the environment. So the environment name, so whatever we have provided here, whatever you want, you can provide your design name. I am saying UMS means user management service node port. Okay, and the variable I have given here is URL. Okay, and what is my initial value and then current value, it is going to be the same, so which is nothing but this one. Okay, so whatever the node public IP, right, and 31231. So let me copy it and then paste it. Okay, so no slash at the end, you can see, right? So http:// public IP of worker node : 31231. So it is the same thing here, automatically replaced. So let me click on add, right? So I have the UMS node port. So let me close it here. And in the environment, this is no environment. If I test, so it will not go anywhere, could not send request. Okay, so let's select the environment UMS node port and test our health status, whatever we have tested here. So this is the same health status. Okay, here it is working. So here also it should work. Okay, so you can see that user management microservice up and running. So this request sent to our respective container present in our Kubernetes pod or on our cluster, right? So now let's go ahead and then create the user management create user. So this user, whatever you are creating, should be present in our MySQL database, whatever we created here. Okay, So kubectl get pods. Okay, so whatever the user you are creating via user management service should be present in this MySQL. We are going to test that later. Okay, so now let me go ahead and then create that. So if you see here in the body, you can see username is admin1, email, role, enabled, true, first name, last name, and then password. These are the things we are going to post. So let me say send. So it will post to this environment, and then user should be created. Okay, so you can ignore this 500 internal server error. So this is coming because of some message you are seeing here, right? User will be created, but you will get this error because it's underlying one more microservice, which is nothing but notification microservice is not up and running. We just deployed the user management microservice. So how I have written the code is create the user and send the notification to the user, whoever we provide the email here. Okay, so what it is sending is it is not able to post the data to notification/send, which is nothing but the notification service under 8096 port to send the notification and then do that, because notification service we really didn't deploy, so it is not going to work. But user will get created, you really don't need to worry. So that you can verify using the list users service. Okay, so user management/user, so that is the list user service. So we created user, now list user service we are testing. Okay, so now you see that user got created, which is admin1, and then all these details. So if you want to update the user, so currently user has fname1 and then lname1. So if you want to update the same user, so with fname2 and then lname2, so you can just update it. Okay, and then send it, so that changes got reflected. So now let's go and then list the user one more time. So you can see that fname2 and then lname2 got updated. So if you want, you can go and then update the same things the way it is required. Okay, so now these changes are done. If you want to delete the user, so my username is admin1, right? So if you see here, so my username here is admin1. Okay, so using the username admin1, earlier it is 2, just replace it with 1. So user/admin1 and then delete it. Okay, so now user should be deleted. So if I go and then list the users one more time, no user is present. Okay, so now let me go back and then create the user one more time. So now the user got created, list the user one more time, and user is there. So, and if you want, we can create one more user. So I'll say admin2 and Kalyan2, and just I'm giving some 2 users. Okay, so and then save and then send. Okay, so I've sent one more user I have created. If I say list all users, I have 2 users now, admin1 and then admin2. So what I'm going to do with these 2 users is we are going to go to the next step. So we have tested all these services, delete user also. So we are going to verify these users in our MySQL database by connecting to our MySQL database. Earlier also we have run this MySQL database command using kubectl run. So it is going to download the MySQL 5.6, whatever is our main container image. In the same way for the client also, it is going to download the same 5.6 container, and from that container it is going to connect to the MySQL host, which is nothing but our MySQL deployment, whatever we have done. And then it is going to take us to the MySQL prompt. So there we are going to run these commands. So let me copy this and I will run this. Okay, so now it will take a little bit. Yeah, so okay, so it should run now. So we are in the MySQL prompt. So first thing is show schemas, so which is nothing but what all databases available. Okay, so now I need to connect to user mgmt schema. So I will say use user mgmt, right? So I connected to that schema, right? So now I will say show tables in that schema. Okay, so now I see users table is created. Okay, so I'll say select star from users. Okay, now if you see that I have admin1 and then admin2 records got created in this database. Okay, so now let's come back here to Postman and then delete the user. So admin1 if you want to delete, or admin2 I will delete. Okay, so deleted the admin2 user, and then if I say list all users, I have only admin1 user. So let's execute the same select star from users. So you see only one admin1 is there. So now you can see end to end that whatever the user you have created already present in our EBS volume, which is nothing but the persistent storage, right? So that's about it. I'm going to quit this. As soon as I quit it, the MySQL client related container is going to get terminated. That respective pod is going to get terminated. Okay, so this completes the creation of users and then deletion using Postman. Okay, so and one more thing we are going to do is we are going to delete all the objects now, so which is nothing but kubectl delete -f kube manifest. Whatever is there present inside this kube manifest, all those files will be executed, and then those files, whatever the objects created as part of that, going to get deleted. Okay, so let me clear this and kubectl get pods. So one more time I'm repeating whatever the thing. So earlier we have this issue, right? So one time our application got restarted because MySQL is not up by that time. In our next lecture we are going to discuss about init containers to fix that type of issues. Okay, so no restarts will happen about our application. Our application should wait till the MySQL container is up. For that we'll implement the initialization containers concept. Okay, but for now let's go ahead and then delete this. About this concept also I have written a little bit here. If you want, you can review the problem observation, what we have observed, and then how we are going to fix it is using init containers in our next section. Okay, so I'll say kubectl delete -f kube manifest. Okay, so all my storage classes, persistent volumes, everything whatever it has created will get deleted. Okay, and once it is deleted, so we can say kubectl get pods, and mostly nothing is there, right? Kubectl get storage class pv comma pvc, all those things. Okay, let's see what is present here. Okay, so nothing, the default storage class other than related to Kubernetes, but rest all nothing, we can see it here. Okay, so if you want, you can even type kubectl get all and then verify the same thing, right? So this completes the section 4 related to EKS storage with EBS block store. Okay, so in 05 section we'll focus on few of the important concepts related to Kubernetes. So liveness probes, and then requests, and then limits, and then initialization containers. Okay, readiness probes, those things. And in 06 we'll focus on, instead of MySQL DB, why we need to use RDS DB, means like custom built MySQL DB present using EBS. Instead of that, as we are in cloud, why can't we leverage RDS database service? So we'll see that in our 06 section. So I'll see you in the next lecture. Until then, bye bye. Thank you.